Hello everyone in first secondary. Welcome to second term. Hope you inshallah the best. And today inshallah we'll talk about our first lesson in geometry, vectors. Let's start by an important definition, scalars and vector and directed line segments. So we have examples to understand the meaning of scalar quantity and vector quantity. So we have the first example is the length of the side of a square equals 3 centimeter, then its area equals 3 centimeters, so the area will be 9 centimeters square. The volume of the cube equals 125 centimeter cube, then the length of its edge equal 5 centimeter, and if the worker needs a day and a half to paint a room, how many days does it take him to paint 4 rooms? So will take 6 days. And what is the position of Alexandria observed from Cairo? So Alex is northwest Cairo at 230 kilometers. A sandstorm flowing from the southeast of Egypt with speed of 70 km per hour. So, which of the above quantities you need a number to express its value, and which is not enough to express its value? So, we have scalar quantities, and the scalar quantities are determined completely by their magnitude only, such as length and area. So any length, area, volume, whatever, so we called this quantity is by scalar quantities. Scalar quantities, we only need its magnitude, and we have another quantity or another quantities, vector quantities. Scalar quantities are determined completely by their magnitude and their direction. So the vector quantities is scalar quantities are determined completely by their magnitude and their direction, such as velocity and force. So we have in vectors quantity, we have magnitude and a direction. We must have a magnitude and a direction. Okay, think and discuss. If a body moves from a point A, a distance 3 meters east, then changed its direction and moved 4 meters north and stopped at the point C. What is the distance covered by the body during its movement? What is the distance between the body and the point A, which is the starting point of its movement? So we have directions, we have east and west and north and south. So we have the horizontal line east and west and the vertical line north and south. So if body moves to right, so to move east, so move to right to point B, then 4 meters north, so we'll move up 4 meters. So the distance here is 3 plus 4. The distance here is 3 plus 4, which is equal 7 meters. But the distance between the body A and the point of its movement from the point A to the point C, we called this distance by displacement. From A to C, we call this by displacement. So distance is a scalar quantity which is the result of AB plus BC or CB plus BA. But displacement is the distance between the starting and the ending points, and in direction from A to C, i.e. to describe the displacement, its magnitude AC and its direction from A to C must be determined. So we call the displacement by magnitude and a direction. So the magnitude from A to C, magnitude AC, and the direction from A to C. So displacement is a vector quantity which is the distance covered in a certain direction. So displacement is a vector quantity because we have distance and we have a certain direction. In the opposite figure, we have AB 6 centimeter and VC 4 centimeter. Calculate the distance and displacement covered when a body moves from the point A to the point C, then returns to the point B. So, distance will be AB plus BC, then return to the point B, so we move 4 centimeter again. So 6 plus 4 and return 4, so will be 14. Displacement, it's mean AB plus BC minus BC. 6 plus 4 minus 4, which is equal 6, in the direction from A to B. So we have direction, so we interest now in direction. In the opposite figure, OX, each ray in the plane determines a direction. So OX determines the east direction and OX dash ray determines the west direction and OY determines the north direction and OY dash determines the south direction. So this example, what are the directions determined by OA, OB, OC, OD? So we say OA 30 north of the east. We say north of the east because we say the OY direction, then we say OX. So we start with north, then of the east. And OB, we say 60 degree north of the west. OC, we say west of the south. Or we can say 25 degree west of south. OD, 45 degree south of east. We have here AB parallel to CD, if AB parallel to CD. So we have EA and BE have the same direction and are carried on one straight line. It's an important EA. We start with the point E, then move to A. So EA ray and BE ray have the same direction and carried on the same straight line, on one straight line. EA and DC, EA and DC have the same direction and are carried on two parallel straight lines. Also, EA and EB. EA, I start from E and move to A, so ray EA. Then I start from E and move to B, so EB. So we say that have opposite direction and are carried on one straight line. And we have EA and CD, EA and CD. So I started from E and move to A. So EA ray and C, I started from C and move to D ray. So we have here opposite direction also and are carried on two parallel straight lines. Generally, the two rays difference